Hello all, welcome back to discussion on wave optics. Today's concept is interference of light. In this session we are going to discuss concept of interference of light, how light waves can overlap each other, what is condition for brightness, what is condition for darkness, and we will see the theory of interference of light. Let us start the concept interference of light. To understand the concept of interference of light, we need some basic terms. Already we have learned in the first step: coherent source of light, incoherent source of light, superposition of the waves, path difference, phase difference. This concept we need in detail. So let us start the few basic concepts to understand the interference of light. The first concept is coherent source of light. Coherent source of light. See here. Coherent source of light means the source of light which emit the waves of same amplitude, of same wavelength, of zero phase difference or same phase difference. Such source of light we are calling coherent source of light. Now diagrammatically how it looks like, that we'll see. See here. I can take a linear source of light. See here. I can take this is the linear source of light. From the linear source of light, consider the light wave can go like this. In this direction light wave can go, or in this direction the light wave can go. From this linear source of light, each point on the source of light is a source of new disturbance according to Huygens principle. If light waves are going like this, how the waves can move? In this fashion the waves can move. These are the waves, they can go like this. Similarly, from this how the waves can go? Waves can go like this wave can go, right? What I said, coherent source of light. Source of light which emit the waves of same wavelength, of same amplitude and zero phase difference. See here, amplitude mean that is maximum displacement. I can call this is the amplitude, on this is the amplitude, this is the amplitude and this is the amplitude. Two waves having same amplitude, same wavelength. Same wavelength means distance between any two crest you can call wavelength. Similar distance between any two crest, that we are calling wavelength. Or contact like this also. Distance between any two crest you can call as wavelength. Distance between any two crest you can call as wavelength. Look at me. This wavelength are same, and this wavelength are same. Two source of light or the source of light which emit the waves of same wavelength, of same amplitude, along with same phase difference or zero phase difference. Look at here. Phase difference, phase mean what? The state of vibration of the particles. I mean state of vibration of the medium particle. It indicates in a given time where the particle vibrate, or at a given angle where the particle vibrate, that we are calling phase of the wave. State of vibration we are calling. See here how it is. Look at me. At this point the phase is nothing but phi1 value. At this angle, at this position, phase difference is what value? Phi2 value. Here phase is phi1, here phase is phi1. At this point 90 angle available, at this point 90 angle available. So they are having zero phase difference or same phase difference. Look at here also. You can take. At this point phase is nothing but phi1 value. At this point phase is equal to what value? Phi2 value. So look at me. This phase and this phase. I mean at the same time, at same angle, both waves are vibrate. The second call phase of the wave. Same phase of the wave. Simply, if source of light emit the waves of same wavelength, same amplitude, zero phase difference or same phase difference, this we are calling what? Coherent source of light. After this, the one more basic term we need, that is incoherent source of light. Incoherent source of light. Incoherent source of light. Just a reverse of coherent source of light. See here, how to define this? The source of light which emit the waves of different wavelength, of different amplitude, different phase difference or zero phase difference. This we are calling incoherent source of light. How it is source of light again? I can take this nothing but linear source of light. From this linear source of light, consider this nothing but light wave. It can go like this, or we are calling this nothing but light wave. We can go like this. How the waves can produce from this point? From this point, waves can go like this. See here. Then from this, how can take this nothing but the wave? This wave can go like this. Like this wave can go. See here. In this case, amplitude is bigger. You can represent by A1 value. But here, what about amplitude? Amplitude is very smaller. Represent by A2. These waves having different amplitude. Then look at here. Look at me. I can call distance between any two crust. You can call this is wavelength. Then what about this? This is smaller wavelength available. I can represent by lambda. Here bigger wavelength available. What about here? Smaller wavelength available. I can represent as lambda 1 and represent by lambda 2. Two waves of different amplitude, different wavelength, along with the different phase difference available here. Different phase difference means, look at me. See here, this wave actually vibrate at this point. Let us call this phase difference is phi 1. But what about here? This phase difference is equal to what value? Phi 2. So here, there is phase difference between this wave and this wave. Here it is vibrate at 90 degree. But what about here? It vibrate at 270 degree. Different phase difference. So, incoherent means any source of light which emit the waves of different amplitude, different wavelength along with different phase difference, those we are calling incoherent source of light. After this, we need to understand the one more concept that we are calling path difference and phase difference. See here. Let us take. After this, we will see path difference and phase difference. Path difference and phase difference. Phase difference. Path difference and phase difference. See here. Now I can take source of light. To understand path difference and phase difference, simply we will see, I know what is the relation between path difference and phase difference. That concept we will see now. Look at it here. Now simply you can take this is nothing but source of light. From the source of light, let us take the rays of light can go like this in this direction. Let us take one more source of light I can take. So I can take this is nothing but S2 source of light. From this S2 source of light, let us take the waves can go and they can meet at this point. So let us consider they can meet at a point P. How the waves can go from this point? From this point, waves can go like this. And from this point, how the waves can move? In this direction, waves can move and they can meet at a point P. What is actually? At this point, I can take a phase difference is phi 1. Phase is phi 1. At this point, phase is phi 2. I can initially understand what is mean by path difference. Look at me. S1P travel at this point, S2P travel at this point. In between S1P and S2P, there is path difference. I mean, there is distance travel. Shall I understand it here? Look at me. In between S1P and S2P, what is the difference? This is the difference. What I can call? See here. See here, this difference I can call. What this one? Del X I can call path difference. Path difference means the difference in distance traveled by two waves. Difference in distance traveled by two waves I can call path difference. Simply path difference I can represent by quantity del X. Path difference is the difference in distance traveled by two waves. This I can call path difference. Simply S2P minus S1P I can call path difference. Then see here. Here phase is phi 1. Here phase is how much? Here phase available how much? That I can represent by phi 2. What is phase difference? Phase difference, simply difference in phase. Simply can represent by phi 1 minus phi 2. Then in between phase difference and path difference there is a relation. What relation exists? See here. This phase difference is equal to 2 phi by lambda into path difference. This relation exists. This is the relation exists. Whenever difference between distance traveled by two waves I can call path difference, and difference in phase of the two waves I can call phase difference. This relation exists. No need to prove this relation. Just remember this. Phi is equal to 2 phi by lambda into del X. Then see here. Then after this, let us take one more concept, superposition of the waves. See here. Look at it. See here. After this, superposition of the waves. Superposition of the waves. Directly we are learning superposition principle. Superposition principle. Look at it. What about this concept? Superposition of the waves. Actually, the phenomenon of interference of light, it occurs due to superposition of the light. The interference phenomena, it is well explained by Huygens wave theory of light. Huygens proved that. Huygens explained well all properties of the light. I mean, whenever two or more waves are overlap each other, what is intensity of the light, how intensity of the light can be added, what is condition for brightness, what is condition for darkness, all concept is explained in interference of light. Then see, initially we will see what is meant by superposition of the waves. What it is? When two or more waves are overlap each other, this phenomena can call superposition of the waves. How superposition takes place, that we will see. Look at it. I can take this nothing but linear source of light. This I can call linear source of light. From this linear source of light, consider this is nothing but one ray. It can go like this or like this. Similarly, one more ray of light, it can move like this it can move. Then from that point, let us consider so many waves are originating. Let us consider. From this point, let us consider this is nothing but one wave. It can originate like this. Like this it can originate. Right or wrong? So this wave has how much displacement? Consider this wave has the displacement of y1. Then from that point, consider one more wave is originating. Look at it. I can take one more wave, it can originate like this. Like this it can originate. Are you following this? Then this wave has how much displacement? This wave has this much displacement. Look at it. Superposition, I say, the phenomenon of overlapping of two or more waves, that we are calling superposition. But see here, crust of the one wave overlapping with the crust of another wave. Similarly, trough of the one wave overlap with the trough of another wave. As a result, the resulting superposition of the waves, it can having the maximum amplitude along with maximum intensity. Like this it is possible. Actually, each wave has the amplitude of what value? That I can represent by A and A, or I can represent by A1 and A2. Look at me. Then what about resultant amplitude? This you can call resultant amplitude. I can represent by capital A. See here. This is amplitude of what value? This is amplitude of A1, and what about this amplitude? This amplitude I can represent by A2. Different amplitudes are available. When different amplitude or same amplitude overlap each other such that the crust is overlapping with the crust or trough is overlapping with the trough, there is maximum amplitude will come for a resultant wave. See here. Now let us take one more way I can take. Look at me. Again from this, let us consider this is the type of the wave originating from that point. Like this. Again, this wave has the displacement of what value? This wave has the displacement of y1. Then from this point, like this nature of the wave also originating. Like this nature also originating. Possibility like this also. See here, what happens? This wave has the displacement of y2 such that the crust of the one wave overlapping the trough of the other wave. Whenever crust is overlapping with the trough, then actually there is minimum amplitude will come. There is minimum amplitude will come. This amplitude again I can represent by what value? A value. See here. In between amplitude and intensity there is relation. Intensity of the wave in the amount of light energy emitted per unit area per unit second. This we are calling intensity of the wave. Theory says that the intensity of the wave directly proportional to square of amplitude. Intensity of the wave directly proportional to square of amplitude. I mean, more the amplitude, more the intensity of the light. More the intensity mean amount of energy emitted per unit area per unit second must be more. Wherever more intensity, there brightness possible. What happens? Brightness possible. Similarly, here amplitude is smaller. Again, intensity directly proportional to square of amplitude. Here amplitude is less value, intensity less value. Wherever intensity less value, the darkness is possible. Maximum intensity, brightness possible. Minimum intensity, darkness possible. Or zero intensity, perfect darkness possible, and maximum intensity, perfect brightness is possible. So that here what happens? Whenever crust is overlapping the crust or trough is overlapping with the trough. Let us take what about displacement of resultant wave. I can take this is nothing but displacement of resultant wave, that is why here two waves are available. One is y1, second one is y2. Wherever crust is overlapping with the crust or trough is overlapping with the trough, then resultant displacement can given according to superposition principle, that is y1 plus y2. y1 plus y2 according to superposition. Similarly, whenever crust is overlapping with the trough, here crust is overlapping with the trough, so that resultant displacement wave can represent. How to represent? Y is equal to y1 minus y2. Wherever crust overlapping with the trough, resultant displacement is added, and whenever crust is overlapping with the trough, resultant displacement is subtracted. That is done according to superposition principle. It says that when two or more waves are overlap each other, the resultant displacement can be added vectorically. How to add vectorically? If crust overlap with the trough, it is added. Whenever crust is overlap with the trough, then simply displacement can be subtracted. Here what happens? Whenever two or more waves are overlap each other, there is redistribution of the light energy takes place. There is modification of the intensity of the light takes place. Look at me. When crust is overlapped with the crust, there what happens here? Whenever crust is overlapped with the trough, whenever crust is overlapped with the crust or trough is overlapped with the trough, there is maximum displacement come, maximum amplitude comes, so maximum intensity. Here maximum light energy of the wave is possible. But in this case, displacement subtracted, minimum amplitude possible and minimum intensity possible, so energy of the light is decreases. I mean, when two or more waves are overlap each other, there is modification of intensity of the light or redistribution of the light energy takes place. Here energy not be created, energy not be destroyed. Here energy maximum, here energy must be minimum. So there is law of conservation of light energy takes place when two or more waves are overlap each other. Then what is concept of interference of light? Concept of interference. See here, when two or more waves are overlap each other, here maximum energy of the wave possible, here minimum energy of the wave is possible. So that interference of the light in what we can define? The phenomenon of redistribution of the light energy when two or more waves are overlap each other from a monochromatic source of light or from a coherent source of light. From a coherent source of light, if two or more waves are overlap each other, then what happens? Modification of intensity of light takes place or a redistribution of the light energy takes place. This phenomena we are calling interference of light. Then let us define. Let us define interference of light. See here. Shall we see interference of light? How to define? The phenomenon of redistribution of light energy. Redistribution of light energy. Redistribution of light energy. Light energy when two or more waves are overlap each other. When two or more waves are overlap each other. or more waves are overlap each other. This phenomena can call interference of light. This is calling interference of light. Then let us see in detail what is theory of interference of light. Before that, again interference can classify into two categories. One we are calling constructive interference, second one we are calling destructive interference. Let us see here. Interference can classify into two categories. One we are calling constructive interference. Constructive interference. Constructive interference. How this is possible, that we'll see. Constructive interference. See here. I can take this is nothing but linear source of light. From this linear source of light, consider again light wave is emitting. From like this light wave is emitting. This is type of the wave emitting of same wavelength, of same amplitude. Look at one more wave can originating from this point. This point, like this it is possible, such that crust is overlapping with the crust or trough is overlapping with the trough. Here two we have different displacement. What can represent this wave? Solid line represent y1 displacement and dotted line represent y2 displacement. Here crust is overlapping with the crust or trough is overlapping with the trough. So that resultant wave will come, the resultant wave of maximum amplitude will come and maximum intensity will come. How much amplitude is available? I can represent this amplitude can represent by R value or capital A value, no matter. See here. Then according to superposition principle, what it is? Y is equal to what value? Y is equal to y1 plus y2. And what about here? Intensity of the light directly proportional to square of amplitude. What is constructive interference? When crust of the one wave overlap with the crust of the other wave or trough of the one wave overlap with the trough of another wave, this interference I can call constructive interference. During constructive interference, the resultant displacement of the wave can be added according to superposition principle, and in constructive interference there is maximum intensity of the wave is possible along with maximum amplitude is possible, and brightness possible in case of constructive interference. Later we will see what is condition for constructive interference. See here. Then I can define one more type of interference that we are calling destructive interference. Destructive interference. Destructive interference of light. See here. Again, I can take this nothing but source of light. So linear source of light. From this linear source of light, consider this nothing but the wave go like this. Then how the waves can emitting? Like this wave can emitting from this point. Like this wave can emitting in this fashion. Right? How much displacement it has? Now displacement can represent by y1. Let us take one more type of wave can emitting and they can overlap each other. They can overlap each other. Like this they can overlap each other. How much it a displacement? It a displacement of y2. This has the displacement of y2. Here what happens? Crest of the one wave overlap with the trough of the other wave, so that resultant wave will come. This resultant wave has upper lower amplitude and lower intensity of the light. This has amplitude of what value? This has amplitude of what value? R. So what is resultant displacement here? In this case the resultant displacement y is equal to y1 minus y2. Y is equal to y1 minus y2. I mean destructive superposition means the interference in which the crust of the one wave overlap with the trough of the other wave, that we are calling destructive interference, and during destructive interference the displacement of resultant wave can be subtracted according to superposition principle, and here intensity is less value because amplitude is less value. What theory says? Intensity directly proportional to square of amplitude. Wherever intensity less, amplitude must be less value. In case of destructive interference, here darkness is possible. In case of constructive interference, brightness possible. On the other hand, in case of destructive interference, darkness is possible. Then we will see theory of interference. I mean, what is condition for constructive interference and destructive interference? I mean, what is condition for path difference and phase difference? That we will see now in detail. The next concept is Next concept you can see theory of interference of light. Clear. Shall I remove this? Theory of interference of light. Next concept is theory of interference of light. Theory of interference of light. This is for 5 marks question. He may ask the question like this: explain theory of interference of light. What is condition for constructive interference and condition for destructive interference? If you explain all this, you will get the 5 marks. See here. To understand theory of interference, now we will take a monochromatic source of light and coherent source of light. From a coherent source of light, consider the source of wave can emitting and meet at some other point. See here. What I can call? Simply this is nothing but one source of light. I can call this is represented by S1, and from this let us consider the ray can emitting. Now I can take one more source of light. Let us consider this is nothing but one more source of light. I can take at S2, and S2 has originating the waves like this. They can meet. Where they can meet? Now both waves they can meet at point P. If rays are going like this, then how the waves can emitting? Like this the wave can emitting, like this. Like this. It can emit at P point. Similarly, like this wave can go, and they can emitting at this point. Consider the both waves have same amplitude, same wavelength. Both amplitude have same wavelength, same amplitude overlap at point P. Then at point P, either brightness possible or darkness possible. I mean constructive interference possible or destructive interference possible. See here. Now explain in detail. Consider this wave had the displacement of y1 and this wave had the displacement of y2 initially. Now in between S1P and S2P, what is path difference? In between S1P and S2P, consider del x is the path difference. Similarly, for one wave phase difference is phi1 and this wave phase difference is phi2, and both phase difference can return. I can take phi is equal to how much? Phi1 minus phi2. Like this it is possible. Right on this. Now we know that one wave has the displacement of y1. How to represent displacement of the one wave? Displacement of the one wave can represent y1 is equal to a sine omega into t. Y1 indicate displacement of one wave, A represent amplitude of first wave, and omega t that represent phase of the wave. Phase means at what angle, at what time the medium particles are vibrate. Similarly, now I can take a second wave. Second wave I taken displacement. The displacement of second wave again I can represent by how much? That is omega t plus phi. Y2 represent displacement of this wave, displacement of second wave. A represent amplitude of second wave, omega t phase of the wave. Phi, what is phi? Phi represent phase difference between two waves, angle difference between two waves. Angle difference between two waves, simply we are calling phase difference between two waves. See here. Now when two or more waves are overlapping at point P, according to superposition principle. According to superposition principle, what happens? According to superposition principle, that y is equal to y1 plus y2. Right. Then again you can write according to superposition principle, y1 is equal to how much? A sine omega into t plus a sine omega t plus phi. Right around this. Then here what is common? A is common because both have same amplitude. Then look at me. This y is equal to a into bracket sine omega t plus phi. right around this. How this is for? This looks like sine A plus sine B. Sine A plus sine B. We know sine A plus sine B. 2 sine A plus B by 2 into cos of A minus B by 2. By this form, if we explain this, then resultant displacement of the wave will come. Y is equal to A, keep it up same, sine of 2A sine of A plus B by 2. See here, 2 sine of A plus B by 2. A mean omega t, B mean omega t plus phi whole divided by 2 sine of A plus B by 2 into cos of A minus B by 2. Cos of A minus B divided by 2. Right around this. 2A sine of A plus B by 2 into cos of A minus B by 2. See here. Like this. Here what values get cancelled? Look at me. A minus omega t plus phi by 2 plus phi by 2. What happens here? This omega t get cancelled. Then what is remaining? Y is equal to 2A kept up same. Here what is remaining? Cos phi by 2 remaining. Cos of phi by 2 remaining. Then how much? Omega t plus omega t. Sine 2 omega t plus phi whole divided by 2. Right around this. Then this total term can represent by what quantity? This total term. How to represent? Y is equal to capital A into sine of 2 omega t plus phi by 2. Sine of 2 omega t plus phi whole divided by 2. What is A? A represent amplitude. What is amplitude here? Amplitude A is equal to 2A cos phi by 2. A is equal to 2A cos phi by 2. I mean, when two or more waves are overlapping at a point P, there is amplitude possible. This amplitude A is equal to 2A cos phi by 2. But I say this amplitude either maximum or minimum depending on path difference or depending on phase difference. Then direct we'll see what is condition for constructive interference and condition for destructive interference. Already we know. When crust of the one wave overlap with the crust of another wave or trough of the one wave overlap with the trough of another wave, that we are calling constructive interference. Look at me. Now directly we will see what is condition for constructive interference. Condition for constructive interference. Constructive interference. Condition for constructive interference. See here. For constructive interference, amplitude must be maximum. This A value must be maximum. If A is equal to maximum, then brightness possible and maximum intensity of the wave is possible. See here. What we know, amplitude of the wave can given by what way? A is equal to 2A cos phi by 2. For constructive interference, maximum amplitude is possible. For maximum its condition, this cos phi by 2 must be equal to 1 value. Cos phi by 2 must be equal to, I mean, wherever cos 0, then it is 1 value, or cos 2 phi, it is 1 value, or cos 4 phi, it is 1 value, cos 6 phi, it is 1 value. To get maximum amplitude, this value must be 1. I mean, for maximum amplitude, how much? For maximum amplitude, this cos phi by 2, either it is plus or minus 1. Plus or minus 1. To become plus or minus 1, what is condition here? The condition can taken either phi is equal to how much? Phi is equal to 0 value, phi is equal to 2 phi value. Because if you put cos 0, that becomes 1. 2 phi becomes cos 180, that is minus 1. Cos 2 phi, cos 4 phi, cos 6 phi, like this. Up to how much? 2n phi. Up to 2n phi. Or directly, the phase difference must be equal to 2n phi, where n value is how much? N value is equal to 0, 1, 2, 3, 4, up to so on. Put n is equal to 0, cos phi 0, cos 0, phi 0. Phi 0 mean cos 0, that is one value. Put n is equal to 1, then become 2 phi. Then this cos phi by 2 is equal to phi value, 180 cos 180 minus 1, plus or minus 1. Then if phase difference is like this, what is path difference? What is meaning of this? Two waves having the angle difference of 0, angle difference of 2 phi, angle difference of 4 phi, angle difference of 6 phi. Then only at P point, resultant wave has maximum amplitude and maximum intensity. Now, if phase difference like this, then what about path difference? Already we know path difference. How much it is? Phase difference has a relation that is equal to 2 phi by lambda into path difference. Now, how much path difference exists? Del x is equal to how much? Phi into lambda divided by 2 phi. Or how much path difference exists? Del x is equal to phi is equal to 2n phi. 2n phi divided into lambda divided by 2 phi. 2 phi get cancelled. Then what is path difference remaining? Path difference is equal to n lambda. What is n again? N is equal to 0, 1, 2, 3 like this. N is equal to 1 lambda. Path difference is lambda. Or path difference is 2 lambda. Path difference is 3 lambda. Whenever path difference lambda, 2 lambda, 3 lambda, or phase difference 2 phi, 4 phi, 6 phi, then only at point P constructive interference possible. I mean crest of the one wave overlap with the crest of another wave, or trough is overlap with the trough of another wave. Then let us see now what is condition for destructive interference. See here, shall I remove this? Condition for destructive interference. Look at condition for destructive interference. Condition for destructive condition for destructive interference. See here. For destructive interference, resultant amplitude must be 0, or resultant amplitude must be equal to, resultant displacement only 0 or minimum, then only the minimum amplitude or darkness of the wave is possible. See here how it is. Again we know condition. Resultant amplitude has 2a is equal to cos phi by 2 is equal to what value? Cos of phi by 2. See here. To be a is equal to 0. To be a is equal to 0. What is cos phi by 2? Cos phi by 2 must be equal to 0 value. If it is 0 into a is 0, then a is equal to 0. For destructive interference, what is condition? The condition cos phi by 2 must be equal to 0 value. Cos phi by 2 equal to 0. 0 into a is 0, then a is equal to what value? 0 value. Amplitude 0, then only darkness possible. To become this condition, what is your phi value? The phi value, either it is 0 value, either it is how much? Either it is phi value, because put phi is cos phi is equal to phi by 2 cos 90 is 0, or how much? 3 phi. See here, 3 phi, or how much? 5 phi, or how much? 7 phi. Then up to what value it goes? Up to this value is got 2n plus 1 into phi, because again n is equal to how much here? Put n is equal to 0, put n is equal to 1, n is equal to 2, 3. Put n is equal to 0, then become this value 0, so this becomes phi. Put n is equal to 1, 3 phi, put n is equal to 2 phi, 7 phi like this. Then see here, what is phase difference for this? Phase difference is equal to 2n plus 1 into phi. I mean, to become 0 amplitude, two waves have the phase difference of phi, 3 phi, 5 phi, 7 phi, 9 phi, 11 phi like this. Up to what value? 2n plus 1 into phi. This is what phase difference. Then what about path difference? See, again we know relation. What relation? This relation we know. Phase difference is equal to 2 phi by lambda into path difference. Del x. Again, what is path difference for this? Path difference del x is equal to how much? Phi into lambda divided by 2 phi. What is phi value? 2n plus 1 into phi. 2n plus 1 into how much? 5 lambda divided by how much? That is 2 5. 5 value get cancelled. Then what is path difference again? Path difference is equal to how much? 2n plus 1 into lambda divided by 2. Lambda by 2. Put n is equal to 0. Then we are getting lambda by 2. Put n is equal to 1. 3 lambda by 2. Put n is equal to 1. Put n is equal to 3. 5 lambda by 2. I mean, to get minimum amplitude, path difference must be equal to odd integral multiple of lambda by 2. N is equal to 0, lambda by 2. N is equal to 3 lambda by 2, 5 lambda by 2. So, lambda by 2, 3 lambda by 2, 5 lambda by 2. 7 lambda by 2, 9 lambda by 2. All these are odd integral multiple of lambda by 2. So that to get the minimum amplitude, path difference must be equal to odd integral multiple of lambda by 2 and phase difference must be equal to odd integral multiple of 5. See here, odd 1, 3, 5, 7. These are odd integral multiple of 5. And this is lambda by 2, 3 lambda by 2, 7 lambda by 2, 9 lambda by 2. These are odd integral multiple of lambda by 2. This is condition for constructive interference and destructive interference. The further study concerned to interference of light, that we'll see in the next session. Thank you guys.